Thanks, Ralph. So to provide a bit of context, so I currently work on a team at Trello that's integrating Trello with some of the internal services at Atlassian. Now, on this program of work, we have multiple teams working together towards this common goal, and that's to get all these systems talking to each other. Now, with any other integration project, they're usually riddled with technical challenges, and they're usually long-running without any visible output until it's actually time to go live. So from the outset, we absolutely wanted to avoid any long feedback loops and ensure that we were tackling each challenge intentionally to be confident with what we were building and maintain development velocity. So on this integration project, these challenges manifested themselves in in-progress code. So we wanted to make sure that we could continue to deploy our code that was not yet in a releasable state, especially when APIs that we were dependent on from our partner teams, when we were blocked by them, we just wanted to ensure that we could continue to deploy our code to production. We had breaking API changes. Now, we needed a method to perform API migrations in a staged manner and safely roll them out. We also had performance concerns as well. So as part of this integration project, we were building a new microservice that would integrate with Trello. Now, with the performance concerns that we had, we weren't too sure if there were going to be adverse downstream impacts. We also wanted to get early feedback. So with an integration project, with that long feedback loop, you want to know whether you're building the right thing. So we wanted to target our early access customers that were already working with our sister teams and to ensure that, that we were actually building the right thing. So how did we work around these problems? Does anyone know? I guess the title of my talk gave it away. So basically, the feature flags came to the rescue in these certain situations. So to level set everyone, we'll quickly revisit what feature flags are. We'll then go through some of the types of feature flags and how we've used them as an engineering technique. We'll also look at how we can evolve them to inform your product and development processes. And then we'll also look at some of the pitfalls we've found in our use cases working with them and leave some practices that we've implemented to manage them. And hopefully there'll be some time for some questions towards the end. So from the internet, the concept of a feature flag isn't new. They've been around for a while, and so some of you may know them as feature toggles, flippers, or switches. But what are they really? Martin Fowler defines it as a powerful technique, allowing teams to modify system behavior without changing code. So, but what does it really mean? What does it mean? Simply put, feature flags are just conditional statements that allow you to decouple your releases from deployment. So when you think about your typical software deployment, you're assuming all the risk from your code deployment, as well as the risks related to that feature. You may encounter data integrity risks. So there's a chance that your new feature might corrupt your users' data, both new and existing. You may introduce code regressions. So you may have inadvertently introduced a memory leak or system crashes because you've misconfigured some setting. There's also the risk that you may also introduce feature regressions that degrade the user's experience. So within your apps, you might have a certain experience that your users are used to. You introduce a new feature, and they don't like it. So with feature flags, we can actually reduce these risks by decoupling new features and code changes from your deployment. So what do feature flags look like? So in this very basic example, I have this is our current sign-up page. Now this experience is starting to look dated, and the team wants to enhance it to encourage more sign-ups by introducing a new experience. So in code, it looks like this. It's a very, very basic example. It's just a function that returns that experience. Now, we want to be intentional about adding this new sign-up page and be able to easily revert that in case sign-ups start dropping off. So how do we do that? We add a feature flag. So with the requirement that we need to revert to the old experience, we have this feature flag. So what I have here is a very basic example. We've got a an if statement. So we've added the toggle router. Feature flags is enabled for. So this allows us to dynamically change the experience that we want to expose to the user. We've also turned the show sign-up page function into a toggle point by moving the old sign-up experience into its own function called old sign-up experience. So at this point in time, we've deployed this code to production. The feature flag is off, and so the user is still receiving the old experience. After we've deployed to production, we then turn the feature flag on. So this is usually turned on at runtime. At this point, the user receives the new experience. So we compare both code paths. With the feature flag off, the users will get their old sign-up experience. With the feature flag on, the users will get the new sign-up experience. So with feature flags, we're able to ship alternative code paths with one deployable unit and choose between them at runtime. Now you're probably thinking that they're just if statements, but there's more to them than that, especially when they're used as an engineering technique or as a means to improve your development process and reduce risk. So at Atlassian, we have this concept of a flywheel in the business context, but I'm going to talk about this flywheel in the context of feature flags. So if you happen to practice continuous integration and continuous delivery, you have the challenge of decomposing your large features into small releasable chunks. So when this isn't possible, it's tempting to have that long running feature branch that allows for the creation of functionality. And before you know it, you're deploying like thousands and thousands of lines of code to production. So with feature flags, we're able to hide that incomplete functionality in production whilst keeping interim development of that feature on your main trunk. So as an engineering mechanism, we've found them to strengthen the benefits of small changes and our continuous delivery practices. So this leads to a flywheel model of development where these incremental updates will compartmentalize your risks, increasing the confidence of your changes, which in turn increases your development velocity. So in this loop, we're basically getting faster and faster with our changes. Now, there are a few types of feature flags, and they each can be characterized by two attributes: their longevity in your code base, and how dynamically they can be changed. Speaking of dynamism, so each of these feature flags can be toggled on deployment. So it may make sense for your features to be toggled on a deployment basis. So you may turn the feature on for a specific environment, whether that's staging or testing. And they're usually configured from constants in your code or configuration file that has already been deployed to that specific target environment. Now, those feature toggles can also be toggled at runtime as well. So you may want to defer turning features on until after it has been deployed. Or the features are scheduled release because of a marketing campaign, for example. So these are usually set at a database level, or more commonly a feature flag service. The feature flags may also be toggled on a per request basis. So sometimes you want to provide your user with a different experience because they happen to be located in some specific part of the world. They usually get triggered based on a specific set of user attributes that's provided in in their context. So that's usually via a browser cookie or some headers that have been injected as part of that request. Now, speaking of feature flag services, we've recently started using Launch Darkly, and I'm going to be using it in my examples today. I should preface that this is not an endorsement of Launch Darkly, because there's many other feature flag services out there. But for the purposes of today's talk, the features that Launch Darkly has isn't particularly unique to it, and they aren't unique to all the other feature flag services as any of the homegrown ones that you may already be running. So most feature flag services will have the option of allowing you to target an environment, as well as target specific users as part of that feature flag. Now, probably the most common type of feature flag that's used as an engineering mechanism is the release toggle. They're just on-off switches that are used to control whether a feature is enabled or not. They're usually short-lived, and are usually removed after each release. They're also configurable at runtime via database or via feature flag service. Now, the neat thing about controlling when a feature is enabled or not allows us to merge in-progress code to the main branch and continue work in the interim. So most CI/CD development out there will talk about truck-based development, where the idea is you have this main branch that all developers are checking in, and the idea behind this is to encourage communication amongst the team. So by doing that, you're basically catching any conflicts early and catching all those bugs early when you're deploying. This ends up becoming a forcing function for your team members to actually keep those changes small and merge on a daily basis. However, for a lot of teams, this is not sometimes possible. So at Trello, for our use case specifically, we don't use this model because of constraints imposed by regulatory compliance. So in the US, we have SOX compliance, and every change that we make has to have reviewers. So with this particular model of development, we can't actually do that. And so instead, we do feature-driven development instead. So with a feature branching model, every developer will work in their own isolated branch. If the feature that they're working on is too large, they'll basically gate that work behind a feature flag and then raise a pull request for review. So once the pull request is approved, the branch is merged in with that feature flag, and that code that's sitting behind that feature flag is now latent in production. This then gives them the confidence to continue development and then merge the rest of the feature in small batches over time. We've also found release toggles to complement our Canary deployments as Canary releases. So at Trello, we run a highly available cluster of stateless services that's sitting behind a load balancer. So you have all these users just going through that load balancer there. Now, when we do our daily deployments, we firstly make a Canary deployment where we push a new version of the code to a subset of our servers. These Canaries are then made available to a small subset of these users. So some of that production traffic is now routed to the new version of the code. So with this new version of the code that we've deployed, it also contains a feature that we've gated behind our release toggle. And once we're ready, we then do a release of the feature on the Canaries by turning this feature flag on to allow it to bake for a short period of time. So by doing this with the Canaries, we can at least minimize the blast radius of those changes just to those set of users we've now turned it on for. And when this is happening, whilst that new version of the code's baking, we're monitoring our logs, our service dashboards, our error monitoring tools, or any support tickets that may be raised by users for issues that have arisen from this change. So at Trello, we use Grafana for all of our dashboards, but you can use whatever makes sense for you. So at least you can understand what the baseline is when something actually goes wrong. For error monitoring, we also use error tracking tools such as Sentry.io. So the neat thing about Sentry.io is it will actually track errors and associate them with a specific release. So when something actually breaks, we know exactly when an error is introduced. So together with our dashboards, we can then see something going wrong, and then quickly roll back that feature, rather than having to completely do a complete rollback. So if everything looks okay, we then roll out to the rest of our production environment. We've also found release toggles to be useful for making structural migrations, such as deprecating a live API and moving on to a new one. So here I have the Trello login page. If you happen to be a Trello Enterprise customer, you may be prompted to log in via SSO if your organization happens to be using Trello Enterprise. So when you're entering your email, we actually make a call to an underlying API that will check to see whether it's associated with an SSO account. Now, as part of that project I mentioned earlier on, we needed to make a breaking change to this page because we needed to introduce this new API. But how do you make a breaking change to a live system? So with feature flags, we actually take it actually allows you to take a phased approach to making this happen. So the first thing we did was we added the new API. So at the moment, this page is calling the existing API. We add the new one. Now, because this is a new API on the back end, it's not being read by or used by the page, so it doesn't need to be behind a feature flag at all. Where the changes that are needed to be made is actually in the front end. And so we recognize that we need to be able to toggle between those APIs. So we create a new feature flag. So this is Launch Darkly again, where you can define the name of the feature flag, providing a key that can be read in code, and then providing an optional description of what that feature flag is about. We then release a version of the login page containing that feature flag, and that's now gating calls to that new API. So at the moment, so we've done that, and now it's off. It's currently in its off state. After we've done that, after we did that, we then basically turn the feature on, toggling the login page to use the new API. So in this case, we've actually chosen to do a percentage rollout by slowly increasing the number of users using that new API. So for your own purposes, you may choose to target specific users or users matching some custom attributes. Now the neat thing is you don't actually need to be a developer to actually do this. So if you have product managers or designers, you may also want to put them in control of actually turning this feature on. After the feature is baked in, we then do a full rollout of the feature flag, the feature, and all traffic is now being routed to the new API. And because we're diligent, we then remove all the old code that's calling the old API and the feature flag along with it. So that ends up being the end state of the migration. Sometimes we might be building a new feature that has unclear performance implications. So to manage that risk, we might introduce an ops toggle to allow developers or SREs, so site reliability engineers, to disable or degrade that feature quickly in production if needed. Now, they're usually short-lived, but once you're confident that your feature is actually robust, you can actually remove them. But sometimes the ops teams might actually choose to keep them indefinitely as a means to perform maintenance or load shed during periods of high load. So perhaps you run an e-commerce site and you want to disable non-critical features during the Christmas rush to ensure that your site is up whilst that load's happening. So as part of the integration project I mentioned at the beginning of this talk, we needed to build a new service that would enrich a Trello user's information with data from one of those internal services at Atlassian. So this internal service would spew out thousands of events relating to that Trello member to a queue where our new service would be listening to. So we called it the member update service. Now our service would then process each message and make a call out to Trello to update that member. Now, given the volume of messages that we're receiving, we were actually quite concerned of how much load we were going to be placing on Trello. So because the data wasn't that particularly critical, and if messages were backed up, we at least had some fallback to continue processing it at a later stage. And with that knowledge in mind, we basically introduced an ops toggle that allowed us the option of disabling processing if the load coming from this particular service became an issue. I mean, we could have also added a toggle to Trello as well to limit or drop any calls from this particular update service. But where you choose to add that ops toggle depends on your service boundary and ownership. So because our team owns this service specifically, we chose to own that feature flag on this side. So we were being nice consumers. So far we've shown feature flags to be a useful engineering mechanism to amortize and reduce risk. However, they can also be evolved to be beyond just an engineering technique and become an important part of your development process by allowing designers and product managers to get early feedback. So The most common feature flag that allows you to inform product development will usually manifest themselves as experimental toggles. You can use them to perform A/B tests or multivariate tests and determine and validate the feature impact with those metrics. So they're usually short-lived and are usually removed after the completion of that experiment. And they're highly dynamic, so they're likely to change per request. So back to my earlier example, we could have chosen to release a new sign-up page as an A/B experiment. So this is variant 1 and variant 2. And so in this experiment, some users may see the old version, some users may see the new version. Now, as the experiment is running, we collect metrics on things such as conversion rates. And then at the conclusion of the experiment, we then can compare the performance of both variants and then decide the next course of action. Now, A/B and multivariate testing is another talk in itself, so if your team isn't already doing this, I highly recommend it. So it's a nice way to validate your features before actually committing to it. So another neat thing about feature flags is that we can actually target specific groups of users to control user experiences. These types of feature flags are known as permission toggles, and we've found them useful to test in production. So at Trello specifically, we're able to restrict new features on a separate channel that's only visible to our team. So some of you may know this as dog fooding. So we use this opportunity to dog food and QA these new features and ensure the quality of those features before rolling them out to all of our users in production. As I mentioned earlier in the talk, we also needed a way for getting earlier feedback. So with permission toggles, we're able to actually target those early access customers that our sister teams are working with and expose some of that functionality to a cohort of users. By doing that, we actually got a lot of early feedback, and that actually allowed us to understand that we were building the right thing and course correct when we weren't. So I have launched Darkly again, and so with Launch Darkly, you're able to target specific users on some custom attributes that you have defined yourself. So whether that's like a certain set of IP addresses, in this example, like we're using the organization ID of one of the teams at Trello. So whilst feature flags have enhanced our development and product processes, they run with their pitfalls. So at Trello, we have 100 plus feature flags and across 10 different teams. And one of the things that we've found is that they've started to become unwieldy. And because of that, we know that by adding feature toggles, we're actually deliberately adding tech debt. And so as we add more, and as we have added more of them, we've found them to increase the complexity of our code base. And because of that, that's consequently meant that we've had to validate more paths in our code base. More paths to validate in the code base means the increased carrying burden of more unit and integration tests. So this is actually particularly acute for larger development teams that happen to have an explosion of feature flags. So how did we deal with all these concerns? So we've actually found it useful to be disciplined and keep a low inventory of feature flags by keeping them short-lived. We've also continually audited and removed any old feature flags that weren't in use, or where that feature has been completely rolled out. Sometimes it's also useful to maybe create a pull request that removes the feature flag at the same time that you're creating a pull request to actually add them. And sometimes we've found that where we've had too many feature flags, we've run into the situation where it's possible that we've had the wrong extraction and we needed to pull them up to the edge of a feature or service boundary. So some teams actually might take a draconian approach and go to extreme lengths to actually remove the feature toggles. So here I have a manifest of our feature flags. each feature flag will have a default value, just in case the feature flag service, so if launch darkly happens to be unavailable, we'll fall back to this default value. We'll also have an expiry date. So this feature happens to have an expiry date, and this is at some point in the time. This is at some point in the future where we expect that this feature to be rolled out. We then have a unit test that will read each feature flag, which will then go through each feature flag, and check to see whether it's still valid. So this is actually quite an extreme approach. If your team happens to be not disciplined with reminders on calendars. And if it happens to fail, you need to go, your team then needs to go in and remove that feature flag. Or at least reevaluate to see whether it's still needed or not. We've also found it advantageous to make them highly visible. So at Atlassian, we actually, with all of our cross-functional teams, we actually track feature flags on a Kanban board like this. Now, each feature flag that we track actually has a state, whether it's in planning. So we're currently planning on building this feature, and so we've created this feature flag to preempt that. Implementing, so this feature is now currently in the implementing stage. So dog fooding, this feature is currently being tested by our team. And then launching, so we've dog fooded this feature and we're ready to launch, and we're now starting to roll out. And then tidying. So we've released the feature and are in the process of cleaning up all of those feature flags. For each feature flag, we've also found it useful to see a description of what the feature flag is used for. So especially in the case of incidents, like when something's breaking and you're not available to actually provide some context, for your team members, it's actually nice to have a description of that feature flag to understand what it's used for. The state of that feature flag, whether it's on or off, whether it's rolled out to a certain percentage of users, and changes to it. So who changed it, why did it change, and when did it last change? Speaking of changes, at Trello, we've integrated Launch Darkly with Slack. So when anyone on the team actually changes the feature flag, the entire team is informed of that change. So it's visible. We know when someone changes a feature flag in production. So this helps our operations teams actually see when something's going wrong. We also expose the set of feature flags available in our staging and production environments. So for internal users, so for our team internally, we have this menu up here that shows all of the active feature flags, And so with this particular menu, we can actually toggle between the 3 different features here and actually test those different states. For our end users, we also keep a snapshot. So we actually use Help Scout for our support ticketing system. And when those users raise a support ticket, we also include a snapshot of all those feature flags that were enabled at the time. And this actually allows us to quickly troubleshoot what's broken and actually fix it. Now, for some of you that don't have support teams or the capacity to manage the carrying cost of feature flags, it may be worth considering alternative approaches to rolling out a feature without the need for them. So it's possible that you may be able to safely, logically break parts of that feature down and then roll it out. So in review, we've found feature flags to reduce our risk, so we've been able to decouple our feature releases from our deployments by isolating that new code and minimizing the blast radius of those changes. You have confidence that when you release, nothing's going to break. And using feature flags, when something breaks, you can actually dynamically turn it off without having to actually do a complete rollback. assuming you can actually do a complete rollback. We've also found feature flags to improve our velocity by keeping our work batches small. So, as I said, that flywheel model, by keeping it small, we've been able to just continually release whilst we were blocked on our dependencies. So with smaller releases, it has meant that we've been able to scrutinize our changes a lot more thoroughly. So as I said, with feature flags, with our development, whilst they do help with your development processes, they are deliberate check debt, and they actually add complexity to your code base over time. But with those practices that we've implemented at Atlassian, if you manage them properly, they'll actually ensure that you will ship with confidence and velocity.